Hello my dear champion, welcome back to our channel Deeksha Karnataka. Today I am here with your another session in top 30 PYQ of KCET, and I have brought two more important chapters in our series, which is continuity and differentiability and application of derivative. They are the similar kinds, so I have clubbed them together and brought their top 30 PYQs. Okay, so I hope you'll enjoy this session. I hope you'll learn from it, and you can say that you have practiced some questions with me in mathematics for KCET. Now this is very important, right? Because right now you're giving all of the energy for only PU2. That is more important right now, but you also need to practice questions in KCET, and for that you have been asking me in the different videos, sir, can you give me next video of KCET? So this is the session I have brought top 30 for all of you. Now if you have joined me in this journey, how do you join that? By subscribing to our channel. If you have joined me already, well, good and done. But if you are still not joined me, if you've still not subscribed to our channel, subscribe right now to continue this amazing preparation for your PU2 and KCET. Okay, and if you like this session, don't forget to give a thumbs up, because everything that you do, whether you comment, whether you like, whether you watch our sessions, it gives us more and more motivation to come back here and deliver a better and better class every time we are here. Okay, so next let's start. Now, on your popular demand, we have brought back your Abhyas KCET 2026 test series. This was actually launched a little later last year, but since you've been all asking me, all of the teachers, that, sir, when can we have the test series for Abhyas? As soon as possible, can we have it? And so here it is for all of you, Abhyas KCET test series for the year 2026, the improved version, the strong, the reimagined version of your Abhyas. The features you can see, 35 KCET tests. You all ask, no sir, is the PYQ enough? Is solving this much question enough? For that, the answer is here. If you solve 35 KCET mock examination, KCET test, which includes both part test and full length test, so 35 full length and 4 free part tests will be given there. Okay, so total of 35 KCET tests. In that you also get chapter wise KCET PYQ for PU2 for the last 10 years. Real KCET exam pattern and timing is followed in this test series, and we also have the subject coverages: physics, chemistry, math, even biology is also there. So PCMB coverage will be there in the Abhyas KCET at all the price, that offer price, that early bird price is at 1499. Take it right now. Take it right now if you are really looking to get a very good rank, okay, in your KCET examination. You want to know how can I say that? Look at your toppers. Your toppers produced 171, 443, 693, of course by their effort. It was all their effort, but we helped them by solving more and more questions, by practicing more and more mocks. Okay, so we were just helping them. It was all their efforts. So if you're putting efforts, if you want to channelize your energy, this is the test series to do that, to get the top rank, to get into the desired college of Karnataka, which is as good as your NITs and IITs. Is it really true, sir? You might have this question. Is it really true, sir? Look at the packages that they get. The top 5 colleges of Karnataka have very good packages. When you compare them with IITs and IITs, they are very, very reasonable. Okay, that's why I'm telling you, the colleges are very good. The placement of CS department is very, very nice. So that can happen with good rank. And here it is, your toppers telling you the story. How many are there? So trusted by 2025 KCET toppers, 2025 KCET toppers, 1,265 selections, 21 top rank in top 100 ranks. Okay, top 100 we had 21 ranks. Okay, so that's why this is the recommendation from your seniors. Take it right now. Early bird offer is at 1499. You might miss it, and then prices might go up, or you might lose time to solve all the 35 tests. Okay, so that's why take it right now. You asked for it. We have brought back. Our team has worked a lot on this to recreate this test. Okay, and bring it this alive for all of you. So let's start. Session today is what? Today's session is on the top 30 PYQ of the chapter continuity, differentiability and application of derivative. These are the questions I have taken first for AOD right now. Okay, AOD. A stone is dropped into a quiet lake. You can see the year mentioned on the right column, on the right side. Quiet lake and waves move in a circle at the speed of 5 cm per second. Speed of 5 cm per second means your waves are going like this. So what is changing? The radius is changing, sir. So we have the value of dr by dt now as 5 cm per second. Okay, it's very important to identify the given value, right? Next, At that instant, when the radius of circular wave is given as 8, means the r is given as 8 centimeters, they're asking us how fast the area is enclosing, right? How fast the enclosed area is increasing, right? So dA by dt, this will be what? Derivative of pi r square, that's the area of a circle. So we get 2 pi r dr by dt. 2 pi, what's the value of r, bacha? R is 8 here, and dr by dt we all have is 5. 5 2s is 10. 10 into 8 is 80. Answer is 80 pi centimeter square per second. Option D. Option D. The first question in top 30 of the session today is done. That easy. I did not make the question, this is a PYQ. So if you are able to solve this question very easily, good for you, you're prepared, means your preparation is on the right track. Next question number 2 for all of you. A balloon volume change problem, okay? This is both on the rate of change problem. Okay, sir? Because we all know that in AOD we have 3 types of questions: rate of change, maxima, minima, and increasing, decreasing function, right? I have brought back in the session all types of varieties. A balloon which always remains spherical is being inflated by pumping this air. Spherical means volume concept is there. You're filling the air. Filling the air means what? Filling the air means increasing the volume. Yes. So you have dV by dt given as 10 cubic centimeter means 10 cm cube per second. Cubic centimeter means 10 cm cube per second is the rate of change of volume. Okay, find the rate at which the radius of the balloon is increasing. They are asking us to find dr by dt. Any problem? Of course not, sir. Volume formula 4 by 3 pi r cube, not a square. It's a volume, 3 dimensions. Okay, so differentiate this. Done, sir. 4 by 3 the constant as it is. We get 3 pi r square into dr by dt. 3 and 3 is cancelled, which leads to what? Which leads to here 4 pi r square dr by dt. So I want the value of this. This is given as, what is that? 10. Right here, 10 upon 4 pi r square equals to dr by dt. Do we have the r value? Yes, it is there. 15 centimeters. So r square will become 225. So we have now dr by dt equals to 10 upon 4 pi into r square, 15 square, 225. Check. Check. 200 into 4 is 800. 25 into 4 is 100. Add them, 900. What is my answer? What is my option? You can do the calculation in any way you want to. I have done in one of the ways that I like. Okay, your preference, your calculation speed is completely dependent upon you. How do you want to track the question? How do you want to crack the problem? But here it is, my way of doing calculations. Okay, if it is working for me, I'm going to continue like that, right? Number 3. If x is real, then minimum value of x square minus 8x plus 17 is what? Okay, minimum value, first step is to find the critical point. First step is to find the critical point. How do you find that? Derivative dy by dx. What is that? 2x minus 8. Put it equal to 0 to get the critical point. We know that very well, sir. X is 4. If you have more than, listen to me, if you have more than one critical point, you go and find the second derivative and check the nature. Second derivative is more than 0 means minima. Second derivative less than 0 means maxima. This all you will do when you have more than one critical point. In this question, how many you have? You have only one critical point. In that case, do not worry about anything, just put it back in the function. So y value at what? At 4. So replace x by 4, you get what? 4 square minus 8 into 4 plus 17. 4 square is 16 minus 32 and 17. Sum of these two is what? 33 minus 32. Answer is what? 1. Option is C. This is your y minimum. Only one critical point. If you want, you can find the derivative. You'll get what? Positive 2. 2 positive means minima. Agreed, right? But in this case, or any question, if you have only one critical point, put it back in the equation. If you don't have any option like not defined or not existing in nature. If the option is not having undefined, none of these or not existing in nature, directly take the answer as putting the value of the critical point in the function. Next, fourth one, sir. Having fun so far? No problem, right? Yes. The rate of change of area of a circle with respect to its radius. Very simple. Area pi r square. Rate of change of area with what? The radius. 2 pi r. 2 pi r value is 2. Put it here. You have the answer as 4 pi e. Answer as 4 pi e. D. Done. Problem? Of course not. The simplest question of all. Next. The function given here is strictly increasing. Word is very important. Strictly increasing is very, very important. It will change how the interval will look like. If you had only increasing, you can take closed interval. If you have strictly increasing, you cannot take that. You have to keep the open interval. That's why I said the word strictly matters here. Let's check. How do you find this again? Derivative will find, sir. Why, sir? To find the critical point, we get 2x plus 2 equal to 0. I get x value as minus 1. After this, number line, sir, this is going to be what? Positive, because the coefficient is 2. Means positive coefficient of x will give me plus on the right hand side. Over here, minus. This is negative infinity and this is positive infinity. You want it to be increasing. You want it to be increasing means I want derivative of x to be more than 0, and this is this area. Check here, plus sign. Derivative, any value you put here in this range. 0 you put, 2. 1 you put, 2 into 1 plus 2. For any value between minus 1 and infinity, the derivative is always positive. Hence, the given function is increasing in that domain. Minus 1 to infinity. Open at infinity always. What about this? Closed? No, sir. The word is strictly increasing. Got to remove the close and write the open interval. Getting the difference? Why it is not option D? Because they have mentioned the word strictly increasing. If that was not there, answer would be option D. Clear or not? Clear, sir. Next question. Sixth one. The rate of change of the volume of a sphere with respect to its surface area. Okay, sir. They are saying volume by surface area. So unfair, sir. Such a difficult question. Cannot solve. We can never solve it. Oh my God. Oh my God. We can never solve this question, sir. Really? Really, we can never solve this question. This is a case of simply parametric form, sir. If somebody knows the derivatives properly, they know this is a piece of cake. This is a question of parametric form. I know you can differentiate V by S, but you can differentiate V by R and S by R. This is R, I hope you get it. Differentiate this, you'll get differentiation of volume, which is 4 by 3 pi R cube by derivative of, this is R, okay? 4 pi R square. The surface area of what? Surface area of what? The sphere, okay? We get here this, you know this, you'll have 3r square, 3 and 3 will cancel, so we have 4 pi r square. Over here you'll have 8 pi r. No problem. 2 will come here, it will become 2r, so 8 pi r. Pi cancel, 4 2s are 8, r cancel. The answer is r by 2. What is r value? 4, sir. Put it back here, 4 by 2. What is the answer, sir? 2. Option you check. Option A. Option A. A question can never come simpler than this. Yes, just if you know the parametric form, the question is dealt with. If you don't know, you will be stuck and lose marks. Next, question number 7. The maximum value of this function. I told you, even though I brought top 30 of both the chapters, but I've included different concepts altogether. Okay, they're all unique in nature and they're all helpful to you in building confidence and learning for our KCET prep. Okay, what are we doing today? We are doing KCET practice, because in amidst of all the practice that is required for PU2, we don't want to forget about KCET also. We have end goal is to get into the desired college of ours, right? We have a dream about getting into a top college. So for that, we need to solve. We cannot forget the questions of KCET, and that's why I'm here to help you practice that as well. Okay, in the best what I can do right now, I'm here to give you top 30 of this KCET series. You can do more practice. How? Take Abhyas KCET. Take Abhyas KCET test series, and if you do that, what will happen over there? Simply practice more and more mocks, solve questions, analyze it, improve on it, and be a topper. Question number 7 now. Maxima, we have to find out y equal to 1 by x power x. Take log, sir? No. X upon minus x. What have you done, sir? What have I done? Nothing. Exponent rule, right? The reciprocal law I have applied in the exponents. Now you take log. Log y, log of x and minus x comes here. Log of x and minus x comes here. Minus x comes in front and log of x. Now differentiate. You have 1 by y dy by dx. 1 by y dy by dx equals to, check here, minus sign outside, you'll have differentiating log, you'll get 1 by x, differentiating x, you'll get 1 into log x. So as it is, log x. Cancels, please. What I have dy by dx equals to minus y 1 plus log x. Okay, what is the y value? Put it here 0 first. I'm taking dy by dx as 0 to find the critical point. What is this? Minus x power minus x 1 plus ln x. We all know that exponential function can never be 0. This is a non-zero value. So what I get from here? 1 plus ln x equal to 0. So I get ln x equals to minus 1. I get x equals to e power minus 1. How come, sir? How come, sir? Think about it. If you take or convert log to e, what happens? The base of the log becomes the base of the exponent. What is the base of the log over here? Exponent, e value, natural log, e value. E becomes the base of the exponent, right? And x becomes the subject now. So what is the value over here? 1 by e. How many critical points we have? Only one. Do we need to find the, second derivative? Do we need to do that? No. If you have more than one critical point, then you go and do that. But you have only one critical point, so you just simply put the value back in the equation. We have this as, check, 1 by x power x. So what is the 1 by x? 1 upon y and 1 upon y. I get 1 upon y as simply, e as simply e power 1 upon e is the answer. C. 7th is C. Got it? Simple question. Next. Question number 8. They're asking us a stationary point. Something very new, sir. I don't know how to solve it. Same as critical point. Stationary point is same as the critical point. How do you find it? Derivative, put it equal to 0. Okay. We just solve this question. Y equal to x power x we have. We'll take ln y. We'll take x, ln x, because this x will come as the coefficient. 1 by y dy by dx. This will be coming as 1 plus ln x. We just differentiated it. Check here. 1 plus log. Yes. So we get derivative as x power x 1 plus ln x. How come, sir? Because this y will go over there. Y value is x power x. Stationary point means critical point. Put it equal to 0. X power x 1 plus ln x. This is the exponential part. No, never 0. Means 1 plus ln x is 0. So I get ln x as minus 1. X as e power minus 1 means 1 by e. This is the stationary point. Option B is the right choice. Worth it? Very simple. Yes. I thought I forgot to write the option for the question number 7. 8th is done. Next. 9th. The maximum area of a rectangle inscribed in a circle. So whenever you try to increase the area of a rectangle inscribed in a circle, it becomes a square, bacha. It becomes a square. Remember this property. Okay. If you try to maximize the area of a rectangle which is drawn inside a circle, this particular figure becomes a square. The rectangle turns out to be a square when you maximize it. So check here. The radius is given as 64 means 8 square. This is, the radius is 8 here, here also 8. They are saying it is going to be what? A square. The property is square means this side will be A, this side will also be A. It's a square means we can apply the Pythagoras theorem. So apply here. Diagonal square will be equal to, or basically the hypotenuse square will be equal to side square sum. Okay, so I get 256. I get 2a square, cancel 2 with this. I get here 128. So value of a square is what? 128. What does a square means? Area of a square. So 128. Answer is B. How come, sir? Can you explain again? I will. The point is, if you take a rectangle inside a circle, okay, and try to maximize the area of the given rectangle, it turns out to be a square. On that content, what happens here is, on that context, this becomes A, and this will be the radiuses, right? So 8 plus 8 is 16. So if you take the Pythagorean theorem applied over here, apply the Pythagorean theorem over here, you get 16 square, 2a square. Answer is 128. A value is option B. Question number 10 now. The last of your simple question from, this is the last year question from your AOD. Minimum value of this. Sin x can go till -1 to 1. If you apply -1 over there for sin x, you'll get 1 minus of -1. Answer is 2. That's the maximum value, right? That's the maximum value. What about minimum? When you put 1. So 1 minus 1 will be 0. So minimum value is option A, 0. Correct now? The two ends of sin x is what? -1 and 1. Okay, the boundaries. When you put -1, you get 2. When you put 1, you get 0. So the minimum value is 0. Now it's time to solve questions from continuity and differentiability. One of the popular questions on the definition of continuity, you can see on the screen right now. The given function is continuous means the limit will be equal to the function value at the point. For limit, I'm going to use this particular function, 3 sine pi x by 5 x, limit x tends to 0 equals to f of 0, right? F of 0. Now the point here is, bacha, that if you put the limit in the value of x as 0 in the given limit, it will become 0 by 0, which is indeterminate form. So how do you solve this question? We can use standard value of limit and everything, but the easier will be applying LH rule. Since we have to solve the question faster, right? So I simply apply LH rule. What is LH rule? You differentiate under the limits and limits remain same, okay? Limit x tends to 0, differentiate please, you'll get 3 pi, derivative of sine is what? Cos pi x. How come pi, sir? How come pi, sir? Check here. So sine derivative will be cos and derivative of pi x will be pi, right? What about 5x? It will be simply 5, sir, and this is equals to what? F of 0 is 2k. F of 0 is 2k. Now put the value of limit x as 0, you'll get cos 0 as 1. So 3 pi by 5 into 1 equals to 2k. So 2 comes over here, you get k value as 3 pi by 10. Excuse me. 3 pi by 10, no? K value as 3 pi by 10. Option B. Option B. Fair enough. 12th one. X is given, y is given. This is a parametric form question. Apply that. Derivative to the square. So we'll get what? Derivative of y with d theta upon derivative of x with d theta, the whole square, 1 plus. Check here, derivative of this will be what, bacha? A 3 sine square theta into sine derivative is cos theta. Here also we get a into 3 cos square theta, right? And over here what we have, cos derivative will be minus sine. Okay, again we have whole square, a cancels, 3 cancels, this sine also cancels, this one of the sine, cos cancel this particular cos, 1 plus I have sine theta by minus cos theta the whole square. So this is nothing but 1 plus minus tan theta the whole square, 1 plus tan square theta sec square theta Option D is right. Option D is correct. Simple problem. Parametric form application. Question number 13 now. The function fx is given as gif of x, okay, is continuous at only non-integral value. The given function is continuous at only non-integral value, so option B. How come, sir? Think about it. Draw the graph. Close, open, close, open, close, open. So at all the integers it is going to be open and close. There will be a break, okay? So this is what? -1, 0, 1, 2, 3. So at every integral value, this tend to be non-continuous. So continuous will be at only non-integral value, which is only 1, in this case 1.5. Okay, x power y, e power x minus y, we are looking for derivative. Okay, this is a logarithmic differentiation. So we'll have y log of x equals to x minus y log of e. Applying log on both sides, right? So y log of x and x minus y log of e. Log of e is what, bacha? 1. So we get here y, I write as ln x, and we write over here as x minus y. Differentiated. So we'll write derivative of y first. So I get dy by dx. Okay. And ln x as it is, plus this time y as it is, and derivative of ln x. So I get y by x, okay, equals to 1 minus dy by dx. 1 minus dy by dx. Do one thing, club it together. So you get dy by dx times of 1 plus ln x, okay, equals to, what is it? 1 minus y by x. Correct, no? You take dy by dx over here. You take dy by dx over here. This becomes what? Take common. So 1 will be from here, ln x from here. You take on that side. So 1 minus y upon x. Okay, sir. So if you check on right now, so you'll have this value. Can you find the value of y by x from here also? I can move the y on this side. So I'll get y ln x plus 1. What I've done? I've taken y on this side and taken y common. So ln x plus 1 equals to x. So I get y by x equals to 1 upon ln x plus 1. This is correct. What I've done from here, after taking the log, I've taken the value of the y over here. It becomes y ln x plus y. Taking y common, ln x plus 1, and y by x becomes what? 1 upon ln x plus 1. So I have the value of y by x. I'll put it back in the derivative. Okay. So check here. dy by dx times 1 plus ln x equals to 1 minus 1 upon ln x plus 1. I put the value of y by x from this particular box. Check. LCM is what? 1 plus ln x minus 1 divided by 1 plus ln x. This is cancelled. So my final result is going to be only ln x is in the numerator divided by 1 plus ln x the whole square. 1 plus ln x the whole square. This will be here and this comes over here, so whole square. Answer is what? Option C. 14th answer C. Got it? Have a look. 15th one. This is the property. I've taught you this, guys. This is a trick over here. Whenever you have this in product with index, here sum and the index sum. Okay, answer will be always y by x. Now you might want to ask me, sir, how do we solve this actually? Same approach. Apply log. Apply log on both sides and get the result. It will take some time to solve it, but you'll get the same answer. What is the trick? If you have here product, okay, product of x and y, power m and n. The index is m and n. And if you have the right side as the sum of the bases to the power sum of the index, the result is given like this. dy by dx equals to what? Y by x. So option is D. Trick over here. If you want to solve it, apply log on both sides and get the result. 16th, tan inverse of x square plus y square is alpha. Tan of alpha differentiated now. 2x, 2y, dy by dx equals to 0. On that side if you move, you get 2y dy by dx equals to minus 2x. So you get dy by dx equals to minus 2x upon 2y. 2 and 2 is cancelled. Answer is minus x upon y. Option is A. 16th option A. Got it? 16th option A. 17th one. Tan inverse of sin x plus cos x minus sin x is there. I'm looking for derivative of this. Okay, let's start from here. Divide everything by cos. Sin x by cos x. Here 1. Here cos x by cos x is 1. Again we have sin x by cos x. Now you might want to think or ask me, sir, why did you divide by cos? Why? How do you get that idea? Because outside we have tan inverse. So I need to get everything inside in terms of tan. Let's start by doing sin by cos and cos by cos. Okay? Check here. It becomes tan of x plus 1 and 1 minus tan of x. 1 minus tan of x. Do you know the formula of this? Tan of x plus pi by 4. How come, sir? Tan a plus b, tan a plus tan b upon 1 minus tan a tan b. Tan of a is tan x, tan of b is tan pi by 4, 1. 1 minus tan of a. So tan x, tan of b, tan pi by 4. So this is nothing but 1 over here. Okay? Now the result we have y equal to tan inverse of tan of x plus pi by 4. Tan inverse of tan cancelled. X plus pi by 4, I'm looking for derivative. Answer is 1. Derivative of x is 1, pi by 4 is 0. So 1. Option D. Question number 17, option D is right choice. Next. For constant a, differentiate this. Now good thing about this question over here, because to differentiate this function, we have to use what? We have to use logarithmic differentiation. Means use logs on both sides and then differentiate, right? But you can see here, the first term is constant in all the 4. So means we don't have to deal with that part first. We deal with the other ones. So the derivative of x power a power x and a power a. A power a derivative is, sir, 0. This is going to be, sir, a power x as it is, and you will have log of a or ln a. This will be what, bacha? A times of x power a minus 1. Polynomial function, right? Now you cross check. A into x power a minus 1, ax log a. Option B. Because this should be 0. Okay? So option B. Yes? Option B is right choice. 19th one. Fx is cos x minus sin x at pi by 6. Derivative we are looking for. Cos x is this. Sin x is this. Right? Excuse me. Curve can be better. Sin x is this. So this point right here is 45 degrees. They are both equal to 1 upon root 2. And over here somewhere you will have 30 degrees. What is 30 degrees? Pi by 6. So at pi by 6, what happens? Cos x is more than sin x. Cos x is more than sin x. It means cos x minus sin x is positive, more than 0. So the modulus I can open directly now. No need to write modulus because this is a positive quantity. Yes, this is a positive quantity. Differentiate now. Cos becomes minus sin. Sin becomes cos. Take minus sin common. We have sin x plus cos x. I want the value at what point? F dash of pi by 6. Minus sin outside. Sin pi by 6 is what? Sin 30. 1 by 2. Cos 30. Root 3 by 2. Take 1 by 2 common. You get minus 1 by 2 plus root 3 plus 1. Option A is right choice. 19th, option A is the right choice. 20th one. This is again a result. Whenever you have a function like this, y equals to root of f plus f plus f, so on till infinity. The answer is very simple, bacha. 1 upon 2y minus 1. 1 upon 2y minus 1. No. F dash upon 2y minus 1. Okay. Answer in this case will be D. Okay. Because in this case, your function is what, bacha? Your function is x. Derivative of that will be what? 1. Okay. So what are you going to do in this case? How do you solve this question? Y square equals to simply x plus y. Because I can write this as, check this out, simply y. So if you square it up, it will become x plus y. Differentiate, you will have 2y and y1, 1 plus y1. Bring on the set. You get 2y, y1 minus y1 equals to 1. Take y1 common. You have 2y minus 1 equals to 1 on that side. That's why I said derivative of the function f. So f dash by 2y minus 1. Always that same thing. Okay, always remember this. F dash upon 2y minus 1. In this case, f dash is 1. Okay, so direct answer. Not required. Okay. D. D is right choice. D is the right choice. Question number 21 now. Okay, sir. Continuous, they have given, find the value of k. Definition of continuity. Differentiate the LH rule. We have ln x log with the base is ln only. Limit x tends to 1 equals to f of 1. Okay. Differentiate, apply the LH rule. You'll get here 1 by x upon 1. Derivative of x is 1. Limit will remain as it is. X tends to 1. This is k. F of 1 is k. I get, put the value here, 1 upon 1 equals to k. It means the value of k is what? Option B, 1. Clear? Next. Fx is sine inverse of 2 power x plus 1, 1 plus 4 power x. In this question, take 2 power x as tan theta. How come, sir? Because there's a formula actually. What is the formula? We'll go to that later. Write this first. 2 power x plus 1, 1 plus 4 power x. 2 power x into 2. Correct, no? Right? I'm taking this power 1 separately as 2 power 1, which is 2. Over here, 1 plus 2 power x power 2. 1 plus 2 power x power 2. So 2 power x is what? Tan theta. Check here. You get 2 tan theta divided by 1 plus tan square theta. Divided by 1 plus tan square theta. This is nothing but sine 2 theta. Now you're getting it what I did? Why I did? Because we have outside sine. We have outside sine. Now you apply this. F of x equals to sine inverse of sine of 2 theta. What is the answer? Please check. Simply 2 theta. So what is the fx value? 2 theta. So check, find the theta value from here. Tan inverse of x is theta. My bad. Very bad. Tan inverse of 2 power x is theta. So I get f of x as 2 times of tan inverse of 2 power x. Differentiate it now. F dash of x, they are asking us f dash at 0. So find f dash of x first. 2 is as it is. Derivative of tan inverse 1 plus 2 power x the whole square. And derivative of 2 power x is 2 power x as it is ln 2. 2 power x as it is ln 2. Put the x value as 0. You get f dash of 0 equals to 2 into 1 upon 1 plus 2 power 0 is how much? 2 power 0 is 1. So 1 square and 2 power 0 ln 2. 2 power 0 is again 1. This is also 1. 1 plus 1 is 2. So this is cancelled. What is the answer? ln 2. Answer is ln 2 or log 2. Option C. Option is C. 22 is C option. Next. 23. X is a sec square, y is a tan square. Second derivative they are asking. First find the first derivative. Parametric form. dy by d theta, dx by d theta. Parametric form. Previous one you got right. Option C is correct. Differentiate y. You'll have a 2 tan theta into derivative of tan. So sec square theta That's the numerator. Denominator now, a 2 sec theta, derivative of sec theta into tan theta. Derivative of sec is what? Sec into tan. Check here. A cancels, 2 cancels, tan cancels, sec square and sec square cancels. What is the value? 1. dy by dx is 1 bacha. So second derivative will be what? A constant derivative, so 0. Answer is option B. Answer is option B. Have a look. 23rd is done. 24th now. If fx is sine inverse of 2x upon 1 plus x square, find the f dash of root 3. Find the f dash. Take x as first of all, tan theta. So theta will be what? Tan inverse of x. Check this out. You'll have f of x as sine inverse of 2 tan theta upon 1 plus tan square theta. Sine inverse of sine 2 theta. You get the value as 2 theta as f of x. Put the theta back in terms of x. So f of x equals to 2 times of tan inverse of x. Theta is tan inverse of x. This is theta, okay? You get derivative now. 2 into 1 upon, or basically 2 upon 1 plus x square. We are looking for derivative of root 3. Value at root 3. 2 upon 1 plus root 3 square, 2 upon 1 plus 3, 2 upon 4. Answer is 1 upon 2. Option A. Option is A. Clear? Yes. Question 24 is very simple. Okay. 25. Derivative of sin x with log x. So sin x derivative with log x derivative. Sin x is going to be what? Cos x goes up, x cos x. Answer is option B. Answer is option B. As easy as it gets. 26th. How do you solve this question? Differentiate and get this form's value. Differentiate then. Let's find dy by dx first. For this, you'll have 2 as it is. Derivative will give me n plus 1 in front. X power, I'll have 1 less value. So n plus 1 minus 1 will be this only. And you'll have for this, please check, 3 as it is. You'll get minus n, x power minus n minus 1. What did you do, sir? This is what? 3 into x power n, right? So I take, sorry, x power minus n, right? So minus n comes as the coefficient, x power minus n minus 1. What formula is this? Ax power n. Derivative is what? A into n, x power n minus 1. Polynomial derivative. Check now. So we have dy by dx 2 into n plus 1 x power n. We have minus 3 into n x power minus n minus 1. Differentiate one more time. Okay. Second derivative. Second derivative you check now. So you'll have 2 times of n plus 1. Now this n will come in front into n and x power n minus 1. Always keep going one power less, so n minus 1. And for this side we'll have minus 3 and already is there, and you'll get what? Minus n minus 1 x power minus n minus 2. Always one less power. So the power was minus n minus 1 that comes in front, and the power is reduced by another value 1. So minus n minus 1 becomes minus n minus 2. No confusion over here. Very simple question. d square y upon dx square. Let's simplify this now. What I have? 2 times of n into n plus 1 x power n minus 1. There comes a plus sign, because if you take the minus sign common over here, it becomes minus into minus is plus. So plus sign comes. 3 times of n into n plus 1 x power minus n minus 2. Check. I've taken the minus sign common, it becomes plus sign x power minus n minus 2. Now multiply x square to this. X square. 1 second. X square d square y upon dx square. So we'll have, I can take n into n plus 1 first of all common. So I have 2 into x square x power n minus 1, and over here I've taken n into n plus 1 common. 3 into x square n in, x power minus n minus 2. Simplify further. n into n plus 1, you get 2 into x power n minus 1 plus 2. That is n minus 1 plus 2. Over here, 3 into x power minus n minus 2 plus 2. Check this out, please. This will be cancelled. I have minus n left, and you'll have over here as plus 1. Over here, you'll have this as plus 1. So this will become plus 1. This will be only minus n. Only minus n. Now check. So this is going to be what? Plus 1. Check this out. 2 into x power n plus 1 and 3 into x power minus n. This becomes what? It will come in denominator same as y. So my answer is coming as n into n plus 1 times y. Option A. A very good question. Not at all difficult. Just because the nature is a little lengthy, you might give up. But you should not. It's a very simple problem. Option A is the right choice. Done. Next. 27. At x equals to 1, the function given like this is what? Check for both continuity and differentiability. For continuity, what is there? Limit of the function fx equals to f of value at 1. Check this out. Limit will be what, bacha? We'll have x cube minus 1, the function, limit x tends to 1 equals to f of 1 means, in this we're going to put, I get here 1 minus 1, 1 cube minus 1 equals to 1 minus 1, answer is 0. They're both equal means, so limit is coming equal to the function value at 1, therefore, you can see that the given function is continuous. Actually, you have to separate this, okay, separate the terms and find the value individually and you'll get both as 0, which is true. So I don't have to prove that because it is a MCQ, so continuous function. Differentiate f dash of x for derivatives. You'll get here 3x square, you'll get here 1. When this is what? X belongs to, okay, 1 open, right? X belongs to 1 open to infinity. 1 open to infinity, and this is what? Negative infinity to 1 close, okay. Right, check here, this is going to be what? 3. Your RHD is 3 into 1 square. How much is that? 3. And LHD is what? 1. So your LHD is not equal to RHD. Hence, non-differentiable. So continuous and non-differentiable. Option B. Continuous and non-differentiable. Option B. Next. 28. Cos x upon 1 plus sin x is there. Okay, this is a good question. Differentiate it and get which of the option is correct. Differentiate now. We'll get dy by dx. Cos will be what? We have to do what? We have to use here quotient rule, right? Derivative of cos we're going to do first. So we'll have minus sine. Keep this as it is, 1 plus sin x. Denominator kept as it is. Then comes a minus sign. At this time differentiate 1 plus sine. So keep cos x as it is. 1 plus sine will give me only cos. Because 1 will be 0 and sine will be cos. So only cos is there in the derivative of 1 plus sine. And we have denominator as 1 plus sine x the whole square. Simplify now. So you have this value as, what is there? Check this out. You'll have this as minus sine x minus sine square minus sine x minus sine square x and minus cos square x divided by minus sine x minus sine square x minus cos square x divided by 1 plus sine x the whole square, and this is what? Dy by dx. One more step, dy by dx. Check this out. This will be what, bacha? I can take minus sine common. I'll have over here sine x. Check this out. I'll get sine square plus cos square because I've taken the minus sign common. That is nothing but 1 divided by 1 plus sine x the whole square. This will cancel this extra whole square. My answer is what? Minus 1 upon sine x plus 1, which is option 1. Correct. Okay. So we can see option B is right. Only one is correct. But before we take a conclusion, let's move ahead and check the other options also. The option 2 is not possible. What about option 3 and 4? We'll see that. So far we have got dy by dx as minus 1 upon 1 plus sine x, which is option 1. I have sec square and I have pi by 4 minus x by 2. Means angle have to be halved. Okay. Whenever we have 1 plus cos, I can use the 2 sin square or 2 cos square form. We have 1 plus sine. Listen to me. We have 1 plus sine, means I cannot use the half angle formula of cos, right? Correct? No, 1 plus cos is 2 cos square, half the angle, and 1 plus sine is, 1 minus cos is 2 sine square, half the angle. So I'll convert this sine in terms of cos. Can I do that? Of course, sir. Cos of pi by 2 minus x. Pi by 2 minus x. What is this value? Comes back to same thing, sine. Cos 90 minus theta is what? Sine theta. Now you apply the formula. 1 plus cos, this is what? 1 plus, let's say cos alpha. It will become what? 2 cos square alpha by 2. So right here, 2 cos square. The angle alpha is what? This angle by 2 means divide by 2. Pi by 2 is pi by 4 and minus x by 2. Divide by 2 means pi by 4 and minus x by 2. The constant minus 1 by 2 as it is. 1 by cos square is what? Sec square. The angle pi by 4 minus x by 2. Looks something conclusive and possible. Check here. Minus 1 by 2 sec square pi by 4 minus x by 2. Minus 1 by 2 sec square pi by 4 minus x by 2. Option 3 is also correct. So 1 and 3 are both correct. So just by looking at one more time to the other options, we saved our 1 mark. Option C is correct, not option A. So not option B. So option 1 and option 3 are both right choices. That is given in option C. 28, option C is right choice. 29. Now, the function given here is differentiable. It means also continuous. Also continuous. Let's apply continuity first. So limit of the function. There's no equality over here. I'll go with this. E power x plus a power x, x tends to 0, equals to f of 0. So we have the equality over here. They'll become what? B into 0 minus 1 the square. Why only that we can take? Because you can see this is a not an indeterminate form. I can put it back over here. E power 0 will be 1 and a into 0 will have b into 1. So I'm getting the value of b as 1. Value of b is 1, right? A into 0 is 0 and e power x, if you put x as 0, you'll get what? 1 only. This will become v into 1, so b equals to 1. We have 3 options as such. Let's find the differentiation now. To get the differentiation, we have to apply f dash of x. You'll get over here e power x as it is. Over here you'll have just plus a. Here you'll have what? B as it is. 2 times of x minus 1. 2 times of x minus 1. Okay. Now find the LHD. So you have LHD as, check this out, e power 0 plus a. So you get a plus 1. Take RHD now. From here, b into or 2b into 0 minus 1. I get minus 2b. They should be equal, right? Okay. What is the value of b now? 1. So right here, minus 2 into 1, which is minus 2. They should be equal because they are given differentiable. So LHD equals to RHD. You get here a plus 1 equals to minus 2. It means the a value is what? Minus 3. A value is what? Minus 3. So minus 3 and 1. Option is C or the third. Done. So we are done with top 29 questions. We are moving to the last one. 30th problem, the last of the question today in our session. Okay. No problem, right? Alright, sir. dq by dx. Find the function q first. Find the function q first. Check here. It's a determinant x times of x square minus 1. With minus 1, what we get? Second element of the first row, x minus 1. Third element, with plus 1, what do we get? Plus 1 we get 1 minus x. Check here, we get here x cube minus x plus 1 and plus 1 minus x. So I have here x cube minus 3x plus 2 as the function q. What is the function x now? Okay, they're not asking that. What is the function p now? P is x square minus 1 from here right away. So differentiate q with x. So differentiate this function x cube minus 3x plus 2. You get here 3x square minus 3. Take 3 common, x square minus 1. This value is same as p. So 3p equals to dq by dx. What is the option? Option is, check here. Option is 3p. So B. A simple question. And this is the end of your lecture in top 30 KCET PYQ that I came for the purpose for you to practice the KCET questions amongst that energy that is going for PU2 boards right now. But we have to do practice of KCET as well. That's why this series is here to help you continue your preparation for KCET. And if you've not joined yet in our journey of preparation of KCET and PU2, join right now. But subscribe to our channel and do join the WhatsApp community that we have. The link is given to get all the updates regarding your examinations, regarding all the videos which is coming up, all the classes which is being scheduled, and also take the KCET Abhyas test series. The Abhyas test series is live now. Okay, take it right now to make use of the test series properly. You have a lot of time. You want to solve more questions. Total of 35 plus, okay, 35 test series tests are there in this, including part test and full length test. Very, very important. Trust me, this is recommended by your toppers of last year, your seniors. You have to take this if you are serious about the preparation of KCET, if you want to get into the desired college of your dream. If you don't, there's a good chance that you might miss out on the on your dream of getting into top college with good stream. Okay, so don't take it lightly. It is very important for you to take a good decision right now and take the test series and solve as many questions as possible using these mocks. That is it for today's class. I'm gonna see you again in the next class. Till then, take care. Bye bye.